So on this section, we will be going over direct variation. And in reality, it's nothing new. It's just the slope, all right? Yeah, the vocab's a little bit different. Right here it says direct variation equations. A direct variation equation, or a direct variation, is described by an equation of the form y equals kx. Now, k is just a number, okay? So y equals a number x. Think about that. Let's make one up. Y equals, I don't know, we could say 1/2 x, right? That's a direct variation. Y equals 5x, y equals negative 2x, y equals 1x. All of those are direct variations. We've been dealing with functions before where we make an xy table and we write it in function form. So a direct variation equation is the same thing as a function form equation. It has y by itself, right? The only difference is that direct variation is a little more specific. It's y by itself, and it just has a number with x, a number times x. Okay? There is no +2 or there is no -5. There's nothing else at the end. Does that make sense? So direct variation is just y equals a number. It could be a fraction, it could be a number, times x. No constant, right? Normally we have a constant when we get function form most of the time. When we get y by itself, you have y equals something x, and you usually have like +3 or -5 or something else at the end. Right here, direct variation is even easier than function form. It is function form. Y is by itself, and it's just a number times x. Okay, so if we understand that, now we can move on to example 1. It says, name the constant of variation for each equation. Now, when they say constant of variation, they're talking about the number that's in front of x that causes it to vary, right? So what is this number really? If you think about it, it's really the slope of the line, okay? So in a direct variation equation, the number in front of x is the slope. Let me repeat that. In a direct variation equation, the number in front of x is the slope, okay? And not only that, I might as well tell you this. Because there is no number like +5 or +7, if you wanted to, you could put a +0. And what ultimately that does is it shows you that whenever you look at a direct variation equation on a graph, you'll see that it crosses through the origin 0, 0. Crosses through the origin 0, 0. Okay? So a direct variation equation is simply y equals a number times x. If you want, you could put a +0 at the end. And that the +0 at the end, because there is no number out here, it causes all the graphs to cross right through the origin. And once again, the number in front of x simply is your m value. Okay? So you know what? I think even better than what they use right here, let me zoom in here. Even better than y equals kx, I think a better option for that would be y equals mx, because we know that m is slope. All right? So you might want to jot that down somewhere in your notebooks, that a direct variation equation equals, and let me actually do this on the side. There it is. This is what you should jot down. Direct variation equation is y equals mx. Now, what is that really? That's just y equals a number times x, any number, right? It could be 1/2, it could be -3/4, it could be 7, it could be 8, it could be -10. And we know that this number right here is going to be the m value. It's going to be the slope. And we all know that slope, we usually like it as a fraction, rise over run. Okay? So again, direct variation, y equals a number x. And we know it's going to ultimately be y equals rise over run with an x right after it. Okie doke? So on this, back to the example 1, slope and constant of variation. It says, name the constant of variation for each equation, then find the slope of the line that passes through each of the points. It's this simple, guys. Look at your line, and they even pick the points for you. They show you this point right here, the coordinate -1, 4, and they show you the coordinate 0, 0. Now, you do have the option of using the slope formula, by doing the x, y, first point 1, 1, second point 2, 2. But why waste time on that when you could just count your rise over your run? Now remember, is this really a positive rise or it's going to be a negative rise? Negative rise. So I'm going to be going down how many spaces? 1, 2, 3, 4. So that's a -4 as my rise. My rise is -4. Okay? And how about my run? From this point over to this point, my run is 1. My run, going that way, is +1. Okay? So we know that slope is rise over run, -4 over 1. So that's our slope right there. You could also write it as -4, but I would leave it as rise over run. And what they're saying is that the direct variation equation, direct variation is simply y equals mx. So what is your m value? It's -4. So your direct variation equation is right there, y equals -4x. And I would leave it, like I said, -4 over 1. Okay, but you could put it as -4 if you want. Does that make sense? So we're really not learning anything new. The only new thing that we're learning is the words direct variation. And what does direct variation mean? It's really a function form equation that doesn't have a constant value being added or subtracted at the end. Okay? A direct variation equation is simply a function form equation that doesn't have a number that's being added or subtracted at the end. Okay? So how about this guy, part B? Again, they're showing us this point right here, that point right there. How much do I rise? 3. And that is a +3 for my rise. Okay? Why did I do RI? Whatever. You're going up 3. How much are you going over? You're going over 1, 2, 3, 4, 5, 6. And that's a +6. So you have +3 over +6. So your m value is +3 over +6, which means you could reduce it to 1/2. And if you wanted to write your direct variation equation for this line that's passing through 0 right there, the origin, that's going to be y equals the slope. Remember the slope with an x. So that's really going to be y equals 1/2 x. They already have it right here. Y equals 1/2 x. Cool? You see, it's easy. Okay. So I don't know why they take it even further. They use the slope formula and they plug in the coordinates and they get the slope -4. Why would you do that if they already give you the graph and you could just count from left to right, the way we read sentences from left to right, that it's going down 4 over 1. Oh, the slope is -4 over 1. And we know that all these direct variation equations that pass through 0, it's just going to be y equals mx. There is no number at the very end. It's just y equals mx. So y equals -4 over 1x is your final answer right there, your equation, your direct variation equation. You guys get it? If we move on to the next page of our book, which you guys don't have the books right now, but we have this example number 2. Now, they might give you the graph and ask you to write down the direct variation equation, or they might give you the equation and ask you to graph it, okay? So, all your direct variation equations, again, will not have a number that's being added or subtracted at the very end. If you want, you could put 0. And you know why I say if you want, you could put 0? Because putting 0 back there is going to help you to remember that you could start from the origin. Because all direct variation equations start from the origin, okay? So, how are you going to graph this? You're going to go to the origin, and from the origin, you're just going to do your slope. What is your slope? It's -6. You want it to be a fraction? Put it over 1. Okay, so I want to do a quick sketch right here so we don't look at the actual answer on the page right here. So if I go to an XY plane and I go to the origin, I start right here. How many do I have to go? How much is my rise? How much is my rise? -6, right? Does that mean I'm not going up 6 or down 6? Down 6. 1, 2, 3, 4, 5, 6. Over 1, you put a dot right there. You connect the dots. guess what? You graphed your line. And that's just a sketch. Over here in the book, they actually show you the exact line. Makes total sense. From the origin, you go down 1, 2, 3, 4, 5, 6 over 1. Get that dot, your origin dot, draw your line, you're good. So graphing is super easy. And once again, all direct variation equations are going to look like this. Y equals a number x. And we already know that this number right here is slope. It does not have a number being added or subtracted, so you could put plus 0. That way it'll help you remember that you could start at 0 on the origin and just go rise up if it's positive, rise down if it's negative, and run with whatever's underneath your m value. Okay? So all of these are really easy to do if I ask you to do a quick sketch of these guys. A quick sketch of this one right here would be to simply go to a XY plane. I could put a plus 0 right here at the end to help me remember that I could start at the origin. And what do I do from the origin? What's my slope? What's my rise over run? What's up 6? 1, 2, 3, 4, 5, 6. And then? Over 1. So you go over 1 to the side. So that's a really steep line going up. And there's your sketch, right? It's that easy. Again, right here, you could put a plus 0 because that helps you remember to start at the origin, right? So if you start at the origin, what do I do from there? I go up 2, 1, 2, and then I go over how many? 3. Now remember, the rise, it could be positive. I mean, it could be going up if it's positive. It could be going down if it's negative. But the run is always positive, okay? So we're going to go over 3. So again, we went up 2, 1 unit, 2 units. Now let's go over 3, 1, 2, 3. And we should end up over here. And we draw our line, put some arrows on it, and you graft it. Really easy to do. Okay? Let's move on to the next.